Right, so you should have been given a booklet that looks like this by your science teacher this week or last week. If you don't have one, then you can just do the lesson on paper. Okay, what I want you to do is turn to the first page. It says Wythnos Cemeg, which means week 1 in chemistry, because that's the topic you're doing now in year 9. What I want you to do is to fill in the date, the title, the nodder words, which is the learning objectives, what we're going to do today, describes Earth structure and how it's evolved over time. And then have a go at guessing what these words mean. It's a nice, easy starter activity. Just fill it in. Okay, obviously pause the slides as we go. Whenever you need to pause, I'll try and help you to press pause, but you guys are going to know where you need to pause to fill it in. Okay, so these are just keywords, some people can see these really easily. So the first one represents the crust, second one represents the core, third one, mantle, and then finally atmosphere. Okay, so that's just a little bit of a start. We're going to describe the Earth structure and look at how it's evolved over time. That's the first lesson we're going to do. So, first things first, this is the Earth. Okay, the Earth is a layer structure. It's got an inner iron core and a molten core. Molten means that it's melted. Okay, so it's more liquid than it is solid. And we've got the mantle and the crust. Okay, the crust is what we stand on. It's very thin in comparison to the rest of the Earth, but that's what we stand on. Okay, so there's a little bit of a description there. Crust, layer of solid rock. Mantle is liquid rock. Okay, so it's actually solid, but it's got properties of a liquid. Outer core then, layer of liquid iron, nickel, and then you've got your inner core. Okay, that's what you need to be able to label and comment on what they are as structures. So if you move on to the next one, this may be a bit of a better diagram. So you've still got the label diagram, then you've got the outer core is thin, has a low density, okay, so it means it's quite light in comparison to the rest of the Earth. The layer down is called the mantle. Its properties of solid but can flow, okay, so it can move, it can flow and move. Outer core is made from liquid iron and the inner core is made from solid iron. So the first bit of your booklet then says to draw and label the structure of the Earth. Okay, I'd like you to include some interesting facts, but the facts that you've also got on the slide. Okay, don't worry too much if you can't draw it in a 3D shape. You can just draw it like circles. So you'd have like your mantle, course. You can just draw it like that. Okay, so that's the first thing you need to do. So pause the screen and have a go at that. Okay, so now we're back. You've all drawn a lovely label diagram of the Earth. You've included all the details like this thin, low density, etc. We're going to move on to a little bit of a review. So again, I'm going to ask you to pause the screen. You've got the words in your book. All you've got to do is fill in the blanks. Obviously, if you didn't get a booklet for whatever reason, then you can just do it on your sheet. So again, pause the screen and have a go at filling in the blanks. So, you've all had a go, now we're going to mark it. The structure of the Earth consists of 3 layers, the core in the centre, then the mantle, and the outer layer of the crust, with the atmosphere. Okay, so we didn't really mention the atmosphere. The atmosphere is the bit above the crust, the air that we breathe in, the atmosphere above the surface. The outer layer of the Earth is very thin compared to its diameter. So you think about the crust, you think it'd be a lot thicker, but it's actually really thin. The layer below this is solid, but can flow. Okay, so you should have filled that in. If you haven't, then you need to go back in, fill it in, maybe mark it in a red pen if you've got access to a red pen. So, next little bit then, we're going to talk about something called Pangea and the start of the Earth. So about 200 million years ago, the Earth looked very different to how it looks today. Okay, it was actually one supercontinent known as Pangea. We were all joined together. They weren't separate continents. Animals were free to walk from this end to this end. Not much human life, but there would have been a little bit. Okay, but over time, if you look at these pictures, okay, the Earth has spread out to what we know today. So all the continents have separated. As you can see, it's been slowly separating over the past 200 million years. So what we know today is very different to what we had at the beginning. Okay, so how did this happen? Who discovered this? Okay, so tectonic plates are why it happened. The Earth's crust is made into large pieces. Okay, tectonic plates. You don't need to know the names of all the different tectonic plates, but they're there, and they move a few centimeters every year. So that's why from 200 million years ago to today, the Earth looks very different. Now, the man who discovered this was a man called Alfred Wegener, or Wegener, or however you want to pronounce it, or Wegener, and he discovered it in 1915. It wasn't until the 1960s, so nearly 55 years later, about 45 years later, was he actually proved right. So for a long time, loads of scientists didn't believe his theory. So he came up with loads of pieces of evidence, but it wasn't until much later did people believe him. So I'm going to show you a little video all about what he discovered and what he believed. There are 6 fill-in-the-blanks to have a go at. Okay, so as you're watching the video, have a go at the fill-in-the-blanks. Obviously, I will then share the answers at the end. With the video, I'm going to put it up here, okay, and it's called Pangea, the History of the Continent. So if it doesn't work quite well for you on the screen, then you can just search for the video on YouTube. Sorry, they're going to play an advert.
Uh-oh, no Wi-Fi at your in-laws' house. It's switching time to a Chromebook. And now it's Netflix time. Watch Netflix offline. Switch to Chromebook.
It looks like they're like joined together at once.
When you look at a globe of the Earth, it is easy to think that our planet has always looked this way, that the continents and ocean basins are where they've always been and where they will always be.
And you see how Africa...
But if you examine the globe more closely, you may notice something curious. Some of the continents appear as if they may have been joined at one time. A good example of this are the coastlines of South America and Africa. When you compare them, you will find, with just a little bit of adjustment, that they match quite nicely, like pieces of a jigsaw puzzle. And see how the island of Madagascar slides next to Africa. The same goes for North America. Its eastern coastline fits nicely around portions of Africa. People have been noticing these kinds of shoreline similarities for a long time. In the early 1900s, German scientist Alfred Wegener believed that in the distant past, later determined to be about 200 million years ago, the continents had been joined in a single supercontinent Wegener called Pangea, and then had split apart, moving ever so slowly around the globe, until they reached their present-day positions. Wegener called his theory of moving continents continental drift, and he offered additional evidence in an attempt to prove his point. Wegener found fossils of nearly identical animals in both South America and Africa. Wegener believed the only way identical animals could be found on distant continents were if the continents had been joined at one time. Wegener also found plant fossils in cold Arctic regions where these plants could not grow today. Wegener believed the plants had grown there before the continents had drifted. Wegener was convinced the continents had drifted. The only problem, he could hardly convince anyone else. Other scientists needed more proof, and that wouldn't come until years later, when scientists mapped the ocean floor.
Okay, so if you didn't get a bit of that, you need to go back and watch the video again. Like I said, if it didn't quite work on your computer at home, then Google, like put in YouTube the name of the video, and you can kind of do it yourself. Okay, so just keep watching it until you get it right. So, little review now. Okay, that's just the YouTube code if you need it at the top. So, all the continents looked like they all joined together. Okay, and he mentioned that the continents look like they fit together like a jigsaw. Okay, the name of the supercontinent is Pangea. So, the big continent, the original continent, is called Pangea. Wegener's theory was called continental drift. So, that's what he believed, the continents had drifted. The evidence he gave was similar fossils, similar rock patterns, and the fact that they all fit together, okay? When you're saying similar fossils, he found similar fossils on different continents, okay? Similar rocks on different continents, especially animals that didn't have the ability to swim, but he found them on different continents with oceans in the middle. The problem with his discovery is he couldn't explain how they moved apart, okay? That wouldn't come until quite later. That's just a summary slide there, so just things that you might want to note down. There should be room in your booklet. It wouldn't come till much later, about the 1960s, okay? We discovered something called convection currents in the mantle, okay? Convection currents in the mantle. I'm going to show you another little clip, and then we'll kind of explain it, and you can fill in the last. So again, this is called mantle convection cells and continental drift. So if you can't find it, or it doesn't work for you now, please just search it on YouTube.
But the huge molten core contributes something else essential for life on Earth. A way of helping to regulate the planet's temperature. It's a remarkable system. Magma heated by the core rises towards the Earth's surface. As it spreads sideways, the Earth's crust is very slowly dragged apart. This moves the continents, creating the Earth's restless and ever-changing surface.
Okay, so it was something called seafloor spreading, where we mapped the ocean's floor and we discovered that the core is radioactive. So our core is radioactive. Now, because it's radioactive, it emits heat, so it's giving out heat, okay? When liquids or gases get warm, what happens is they start to rise, okay? So think about like hot air, it rises up. It's the same with a liquid, so hot liquids rise. When they come into contact with something cool, so the top of the crust there, before the crust is cool, so when it becomes cool again, cold things then fall back down. Okay, so we call it less dense. So because they're less dense, they're lighter, they rise up. And then when they get cold, they become more dense and they fall back down. Okay, so liquids do it and gases. So you might have looked at gases before, but liquids do it as well. Okay, it's why hot air and stuff rises. Okay, so what happens then? You've got your radioactive core heating up the mantle. The mantle is a solid, but it's got properties of a liquid. That's hence why we said liquids can undergo this. It warms up, it gets less dense, it gets lighter, it rises up. Okay, when it hits the top of the crust there, it gets cold again, and it becomes more dense and falls back down. Okay, these currents then, a little bit like a conveyor belt, cause the tectonic plates to move. Okay, because the movement of them going in a circle like this causes the tectonic plates to move. Okay, so in your sheet then it says draw and describe a convection current. So I've kind of described it. You need to pause the slide now, maybe include a picture, okay, and describe it. And then there's a little review to, so we'll move on now. So draw and label your diagram. So by now you've drawn and labelled convection current, talked about how we know that that causes the plates to move. Finally, again, there's a little review. I want you to press pause, have a go at the review, and then that's the end of the lesson. So the crust is made from solid rock. That is true. Okay, the supercontinent was called continental drift. That's false. Supercontinent is called Pangea. Okay, convection currents were used to prove Wegener's theory. True, okay, because eventually we use them to prove Wegener's theory. Convection means the more dense liquid rises and the less dense liquid falls. That's false. It's the wrong way around. So that's more dense and that's less dense. Okay, the evidence he gave was similar rocks, similar fossils, and the fact that they all fit together. So that's true. Okay, so in your booklet there is then some challenge questions. Okay, there is quite a few pages of past paper questions. I want you to have a go at them. Okay, and then the next lesson is where it says with nos to Chemeg. Okay, so that's it. That's the next lesson you need to watch because you should have had 2 science lessons this week. Okay, remember, if you've got any problems, give us an email, speak to us on Teams. Thank you.